Imagine a spacecraft gliding through the vacuum of space, propelled not by chemical rockets or nuclear engines, but by pure starlight itself. This isn't science fiction anymore. Solar sails are real, they're working, and they're about to revolutionize how we explore the cosmos. Right now, as you watch this video, several spacecraft are riding beams of light through our solar system, demonstrating a technology that could take us to the stars. These aren't tiny experimental probes either. We're talking about functional spacecraft achieving remarkable feats, using nothing more than photons from the sun. So how does light actually push a spacecraft? It seems impossible at first. After all, light has no mass, right? Well, that's where things get fascinating. While photons are massless, they do carry momentum. When billions of these tiny packets of energy hit a reflective surface and bounce off, they transfer that momentum to the object. It's like being pushed by an invisible hand made of pure energy. Think of it this way. When you're standing in bright sunlight, you're actually being pushed by light. The force is incredibly tiny, about the same as holding a paperclip in your palm. But here's the key difference. In the vacuum of space, there's no air resistance, no friction, and no gravity to overcome once you're away from planets. That tiny, constant push from starlight can accelerate a spacecraft to incredible speeds over time. The concept isn't new. Russian scientist Konstantin Tsiolkovsky first proposed light sailing in 1924, and science fiction writer Arthur C. Clarke popularized the idea in his stories. But turning theory into reality took nearly a century of technological advancement. Japan's space agency achieved the first major breakthrough in 2010 with their IKAROS mission. This groundbreaking spacecraft deployed a solar sail the size of a tennis court and successfully demonstrated controlled flight using only solar radiation pressure. IKAROS didn't just prove the concept worked. It sailed past Venus, conducted scientific observations, and operated for years beyond its planned mission duration. But the real game changer came with NASA's Near-Earth Asteroid Scout, or NEA Scout, and more recently, the Planetary Society's Light Sail missions. These projects have shown that solar sails can be practical, reliable, and incredibly versatile for space exploration. LightSail 2, launched in 2019, has been particularly impressive. This small spacecraft, about the size of a loaf of bread, deployed a sail spanning 32 square meters. Using only sunlight for propulsion, it has successfully raised its orbit, changed its trajectory and demonstrated precise control that would make any spacecraft engineer proud. What makes solar sails truly revolutionary isn't just that they work. It's that they never run out of fuel. Traditional spacecraft carry limited propellant, which constrains their missions and destinations. Once the fuel is gone, the mission is essentially over. Solar sails, however, can accelerate continuously as long as they're exposed to starlight. This opens up mission possibilities that were previously impossible. Want to visit multiple asteroids in a single mission? Solar sails can do that. Need to maintain a specific orbit around the sun for decades of observation. Solar sails excel at this. Planning an interstellar mission that needs to accelerate for years. Solar sails are your answer. The physics behind solar sailing becomes even more interesting when you consider different light sources. While our sun provides the primary push for solar sails in our solar system, powerful lasers could theoretically propel these spacecraft to even higher speeds. This concept, called beam sailing, could potentially accelerate small probes to significant fractions of light speed. Stephen Hawking and Russian billionaire Yuri Milner proposed exactly this with their breakthrough Starshot project. Their vision involves launching thousands of tiny spacecraft toward Proxima Centauri, our nearest stellar neighbor, using powerful ground-based lasers. These miniature probes could reach speeds of up to 20% the speed of light, arriving at our neighboring star system in just 20 years, instead of the tens of thousands of years required by conventional spacecraft. Current solar sail technology is already enabling missions that would be prohibitively expensive or impossible with traditional propulsion. NASA's upcoming solar cruiser mission will deploy the largest solar sail ever built, spanning half the size of a football field. This massive sail will allow the spacecraft to hover at unique vantage points between Earth and the Sun, providing unprecedented observations of space weather and solar activity. The European Space Agency is also embracing solar sail technology. Their upcoming Gossamer mission will test advanced sail materials and deployment mechanisms, pushing the boundaries of what's possible with light-powered spacecraft. But perhaps the most exciting aspect of solar sail technology is its scalability. Engineers are designing sails that could span kilometers across, capable of carrying substantial payloads to the outer planets and beyond. These massive light-powered vessels could transport scientific instruments, communication relays, or even supplies for future human missions to to Mars and the outer solar system, the materials science behind modern solar sails is equally impressive. These aren't the heavy, rigid structures you might imagine. Today's solar sails are made from incredibly thin, lightweight materials like mylar or specialized polymers, often just a few micrometers thick. That's thinner than a human hair, yet strong enough to withstand the harsh environment of space while catching and reflecting sunlight for propulsion. Solar sails also offer unique advantages for certain types of scientific missions because they don't rely on chemical propulsion. They produce no contamination or interference that could affect sensitive scientific instruments. This makes them ideal for missions studying the solar wind, cosmic dust, or other phenomena that require pristine observation conditions. The success of current solar sail missions is paving the way for even more ambitious projects. Scientists are already planning solar sail missions to study the sun's polar regions, investigate near-Earth asteroids, and even attempt the first artificial solar system escape using only starlight for propulsion. As we look toward the future of space exploration, solar sails represent more than just a novel propulsion method. They embody a fundamental shift in how we think about traveling through space. Instead of fighting against the cosmic environment with brute force chemical rockets, solar sails work with the natural forces of the universe, harnessing the very light of stars to carry us to new worlds. What other revolutionary space technologies do you think will emerge in the next decade? Will we see solar sails carrying humans to Mars, or perhaps even to the stars themselves?